So welcome to the sixth screencast on global change. There was one more slide on consequences to living organisms that I didn't realize was there, so let's look at that now. Some of the consequences to humans include the fact that many humans may have to relocate due to coastal and island flooding or due to contamination or saltwater intrusion of their drinking water. Second, the rates of diseases, such as those carried by mosquitoes, such as malaria and yellow fever, could increase, and we are starting to see that because these diseases are moving into our climate now that they're warmer or coming down mountains, or moving up mountains, I should say. Okay, next. Some of these diseases may be spread into areas that have only recently been freed from their burden, but then would be re-exposed to it. And all of this will lead likely to economic and social consequences. Okay, now we're ready to wrap it up by looking at the data, putting it all together, seeing if there's controversy over climate change, and figuring out what can be done about it. So the fundamental basis for climate change is that greenhouse gas concentrations are increasing, and that this increase is due to human activity, and that this will lead to global warming. So the general factor of climate change has led to increasing greenhouse gas concentrations, and that this will lead to global warming is fairly established and is definitely not really in dispute among the vast majority of scientists. However, because we have to rely on modeling and it's a very complex interactive world, it's unclear how much world temperatures will increase for a given change in greenhouse gases. This depends on different feedback loops. So let's look again at this one here, which is a positive feedback loop where increases in carbon dioxide in the atmosphere causes an increase in temperature, and the increase in temperature then leads to faster decomposition, which then leads to more CO2. So that positive feedback loop means that the levels of CO2 and the temperatures will continue to spiral upward. Over here we have atmospheric CO2, which is a nutrient for plant growth, so we might have additional plant growth. And those plants will take up the CO2, keeping it in balance, keeping it in check. In reality, though, they've studied this and current plant growth increases have occurred, but that only takes up about 50% of the CO2 that is put into the atmosphere each year. So there were a number of efforts to put a lid on climate change, and the first one was the Intergovernmental Panel on Climate Change back in 2007. And these were scientists very early on looking at the data and putting what they thought was a label on different likelihoods that we will have a trend upward in certain phenomena and the likelihood that this trend is due to human activity. But they didn't really have a PR guy on their team because it's kind of a lame, unexciting labeling system. So let's start here with warmer and fewer cold days and nights over most land areas. The likelihood that that trend occurred in late 20th century is very likely. The likelihood of a human contribution to this trend is likely. And the likelihood, and the likelihood of future trends based on projections for the 21st century make it virtually certain. So this type of language, while being factual, is not really an exciting rallying cry. And it was a huge report, lots and lots of pages, but there wasn't enough information back in 2007 as there is now. And again, it was put out to the public as in a little bit less than exciting soundbite. So what happened during this panel was that the United States did sign on to agree to limit the amount of CO2 levels. The initial goal was something to get our CO2 levels below, let's see, I believe it was 1990 results levels. Okay, so now we're going to take a moment to consider what action this caused, having this report, what can be done to reduce CO2 emissions and mitigate the effects of climate change. Then we'll go back to further panels that have gathered internationally to figure out what to do. Oh, actually, we'll do that now. So in 1997, there was a meeting in Kyoto, Japan, with representatives of scientists from around the world to figure out how to best control the emissions that were contributing to global warming. So actually, this one preceded the 2007 one. So I'm sorry, that's a little bit out of order. But they made an agreement that emissions from greenhouse gases from industrialized countries, that means developed countries, would be reduced to 5% below their 1990 levels by 2012. Now, some of the problems with this agreement was that it excluded requirements for developing nations, including China and India. They did not have to establish emission limits. And the thought there was that they should be given their opportunity to become developed nations. But if you recall from previous slides, they were already producing quite a bit of CO2 into the atmosphere. So at the time, the U.S. representatives signed the Kyoto Protocol, but Congress never ratified it. And some of the reasons for not ratifying it was because it exempted the developing nations. Despite that, there are many local and state governments that did act independently, including the state of Massachusetts, which has come up with its own goals. Okay, so we need to know how to achieve those goals because the CO2 is already out in the atmosphere and it's continuing to increase. So one of the main processes that is being examined is carbon sequestration. Sequestration, think of the word sequester. When a jury is sequestered, they're hidden away like in a hotel while they're participating in a trial. Well, carbon sequestration is similar, where the greenhouse gas, CO2, is taken out of the atmosphere and hidden somewhere or stored somewhere. So one way is to store the carbon in agricultural soils, and that would be typically done by retiring agricultural land and allowing it to become pasture or forest. If you remember from when we looked at the bioproductivity of different types of ecosystems, agricultural land is actually very low on the list. It's not very productive. So if you picture a field of corn and instead you allow it to become a pasture or forest, the concept is that more CO2 would be taken out of the atmosphere that way. So the next concept for carbon sequestration is to take the CO2 out of the air and from other emission sources, such as directly from a coal burning power station, from from the smokestack, so it never gets into the air, taking that CO2, compressing it, and pumping it into something like an abandoned oil well or the deep ocean. And of course, that could have its own side effects. There are some more modern carbon sequestration methods that are being worked on, but so far they are not efficient at all. I was watching a documentary not too long ago about a large plant, I believe it was in Germany, that was sequestering CO2 from the air. And an entire day of operations, 24 hours from this very large plant of trying to capture the CO2 and compress it, only removed the amount of CO2 that an airplane flying from Europe to the United States, one single flight, would release into the air. So a small drop in the bucket with current technology, but maybe better technologies will be coming out in the future. Okay, so key concept reviews, you can read through those on your own. They're all the things that we've talked about. You might want to keep in mind that you do have an open response question for this chapter. and that nasa.gov climate website is a good source of information. I have some other slides for you, though, to just recap this chapter. So stay tuned. Here's the addendum. I have two analogies for you, an elephant analogy and a frog analogy. So let's start with the elephant analogy. So picture an elephant. They weigh about 1 ton or 2,200 US pounds. So picture the elephant and try to come up with a hypothesis about how many elephants worth of CO2 do we put into the atmosphere every year. So maybe you think we put 1 million elephants up in the air of CO2? That's way low. Maybe you think we put 1 billion elephants worth of weight of CO2 into the atmosphere. Also way low. We put about 38 billion tons, so about 38 billion elephants worth of CO2 into the atmosphere every year. Now, if we bumped into these elephants, if they were all collected together instead of mixed through the atmosphere as they are, or if they caused us a problem such as irritation in the lungs from breathing it in, we would probably realize what a serious amount of carbon dioxide that is that's going into the environment every year. And actually, in recent years, the United States has been decreasing the amount of CO2 that they have been releasing into the atmosphere. So that's good news. Whereas the proportion that is produced from China and India is growing. So globally, we're still at about the same number. And it's really time to start bringing that number down when you keep in mind the amount of time that CO2 remains in the atmosphere. You can see that it's just going to accumulate more and more. So the second analogy is the frog analogy. And I'm taking this one from Al Gore, and maybe he took it from someone before him, I don't know. But here's his analogy. If you put a frog in a bucket of boiling water or a beaker of boiling water, the frog would immediately jump out. If you put a frog in a beaker of water, that's say room temperature, and you gradually increase the heat all the way up through boiling, the frog will not jump out and it will actually die, because the frog is only able to compare its temperature to what its temperature was shortly beforehand, and therefore it never really recognizes the fact that the temperature is increasing to a point that's dangerous. So I ask you to take a few minutes to consider how that frog analogy applies to humans and global change. And I have one more slide for you, our final slide for this chapter, and it's a cartoon. It's a climate summit, and one person is saying, what if it's a big hoax and we create a better world for nothing? Energy independence, preserve rainforests, sustainability, green jobs, livable cities, renewables, clean air and water, healthy children, etc. So hopefully I provided enough evidence that you know that this is not a hoax, and I hope that the frog analogy makes you realize that the incremental changes might be leading us to not recognize fully what's going on with the climate and what the consequences might be for humans. And well, that's about it. If you find you have other questions that have not been answered, please let me know.